Okay, let's go back to one of our big motivation questions, which is supposing I have 2 points, A and B. What is the path that gets me from A to B in the shortest distance? So I have lots of possible paths. In order to do this problem, basically what we have to do is parameterize it well. I'm going to cheat a little bit by assuming that if I have a coordinate along here, x, that my path is only going to have one particular value for y at each given x, so that I can describe my path just as a function along here, which is of course true, but if I was going to be very, very careful, I might have to worry about such things. We need to better write down how long this path is for an arbitrary function of y. And so to do that, we take a small piece here, break it up in little pieces, and we figure out how big a little piece is, and then we add them all up. So the total length, L, is going to be integral of all these pieces ds. Now, in order to get these pieces ds, we will break up our ds into a dx, a dy, and our ds will be along this part. And we can see immediately that ds is going to be calculable from Pythagoras' theorem. And just as we did previously, we take a deep breath, extract the dx out, and we get 1 plus y dot squared. So dx on dy for a finite thing is clearly an approximation to the derivative, and provided everything's smooth enough, then as we go to the limit that dx is an infinitesimal, then that fraction just becomes the derivative. Okay, so we're trying to minimize L, and this is exactly of the form that we just did the general form of, so we can come back to it and say the derivative d dx of the partial derivative of this thing dy dot minus the partial derivative of this thing with respect to y must be 0. So this term here goes to 0 because the function square root of 1 plus y dot squared doesn't depend on y at all. This one, the other one does not, however. So in other words, this function of y dot does not depend on x, and therefore we have that y dot is constant. So of course the only path that has a constant derivative is a straight line, and so we've just shown for the first time ever that the shortest distance between 2 points is in fact a straight line. That may seem very trivial, but if you were on a sphere, you would get a different answer. If you were on some other curved surface, you would get a different answer again. And so you finally have the tools to calculate such things for yourselves in non-trivial situations.